Hello, very good morning, class. It is already 9:37. Our scheduled class timing is 9:30. So let us begin. In previous few classes, we are discussing about the canonical representation or canonical and standard form of representing Boolean expressions. More specifically, min terms and max terms. Then we come to know how to write a function in terms of truth table, and from truth table how can we write a function, how can we represent functions in terms of min term and as well as max term. Then what is the relation between min terms and max term, how to find out or how to convert min terms into max term. Then sum of min terms means swap expression, uh, sum of product terms, and we could attempt example number 2.4 in our digital electronics book authored by Morris Mano. And here we come to know that expressing the Boolean function as a sum of min terms means finding the missing literals in a given function. So like here f is equal to a plus b bar c. So we could express f as a b c plus a b c bar plus a b bar c plus a b bar c bar plus a bar b bar c. Now moving further, the other way also, alternate way of finding the missing terms through the truth table. The table is given in 2.5 as a number 2.5. There also we can find out the missing term, that is the f is equal to a plus b bar c. So in a, b and c are missing, so we can extract those information by writing the truth table. Then we also attempted this example number 2.5. Given function f is equal to xy plus x bar z as a product of max term. So final answer was that f is equal to m0, m2, m4, m5. And how to represent max term? We use symbol this pi. For pos, product of sum, and for swap we use summation symbol to express min terms, and pi is used to express max term. So f of xyz is a function is equal to pi of 0, 2, 4, 5. So these are the max term. Max term is obtained after ORing prime or unprimed literals. Then there is a relation between min term and max term, that is the complement of min term is the max term. M j complement is equal to capital M j. And in table 2.6 we can see, suppose f is given xy plus x bar z, so that is the swap expression, and the truth table is written here, xyz 3 variable from 0 to 7. Then f is equal to 1 wherever this is whole true, means xy. So where is the xy? We can see x here, y here, x is here, y here, irrespective of z and z bar. This is z bar and this is z. So at these two places f is equal to xy gives 1. So f is equal to 1, f is equal to 1. Plus x bar z. Let us find out where is this x bar z. So we have here x bar 1, and this x bar z, and this is also x bar z. So at these two locations x bar z and F, hence F gives logic 1 as an output. So you see, so F is equal to xy plus x bar z is represented like this truth table, and at four places, this is one, this is one, and this is one, this is one. So these are called min terms wherever F is equal to 1. This function is equal to 0 at other places like 0, this and this. These are max term. So that is why the complement which are left wherever F is equal to 1, the left are zeros. So these are called max term. So through that now we shall able to tell. So if we want to write the expression in terms of max term of the same function, so we can write summation, sorry, pi 0 2 4 5. And yeah, these are the soft form, as already I have introduced this product, sum of product terms. This is the example of sum of product, and product of sum. This is the example of product of sum. Inside the bracket there are sum, and these sums are connected through the add logic. That is the product. In figure 2.4, we can see how to implement a given function with different levels. So 2.3a is circuit relation of a function expressed in sum of product form. And this is two level means whenever we implement, so the way input signal interface with a logic gate. So this is first level and this is second level. So after two level you will get the output. After passing through the two level of this input signal, then you will get output. And there's the other function, product of sum. So product of sum, you see here at the output we use OR gate in case of sum of product, because sum, this express your sum and this express your product dot. This is product of sum, so this express your product, means add gates express the product term and or express your sum. So product of these sums, that is why product of sum. And this is also two level. See, to get the output, that is F2, an input has to pass two levels of gates, level 1, level 2. Now moving to figure 2.4, what is the importance, why we are interesting to show or to express two level or three level implementation? It is related with your circuit complexity and the time taken to get a particular output. More number of levels, more time it will take, slower is the device, or its computing speed will be lesser compared to lesser number of logic implementation. So that is why we we are learning this. So two level implementation is preferred over three level implementation wherever it is possible. So now three level implementation, you can see the function is given f3. F3 is expressed as ab plus c into d plus e. So you can see here input, to get the output, input has to, not necessarily all input has to pass all three levels, but to get the output, input has to pass three levels, level 1, level 2, level 3. So that is the three level implementation, which is slower than the two level implementation. And this function f3, now you can see same function is implemented. AB, you expand this one, so it becomes AB plus CD plus CE. Same function is implemented in figure 2.4b. So you can see here it is two level implementation. It is two level implementation. So the output available at F3 given in figure 4.2.4b is available faster than the output available at 2.4a image. So this is how we can improve the circuit implementation. Now with this, let us move to other sections. We can now move to Karnaugh map method of minimizing the logic gates. Yeah, as a general knowledge, or this integrated circuit is given in unit 4. So in context of basically logic family, so in digital logic we have small scale integration, medium scale integration, large scale integration, and very large scale integration. It is classified based on the number of devices or logic gates available in particular. So if less than 10 less than 10 gates are available in a single IC, so that is called small scale integrated circuit. If number of gates are from 10 to 1000, then medium scale integration, MSI. If number of logic gates in large is greater than 1000 and less than 10,000, then large scale, and so on, very large scale integration. So it depends on it tells about the package density. Means large number of devices should be there in a small area, then it becomes very large scale integration circuit. And nowadays one more terminology has come, neuromorphic integrated circuit, means very very large, extensively large, like number of neurons in a human bodies, 1000 billion neurons are there in the body. So it goes like that. People have developed such kind of nomenclature to indicate the density. And different logic families are TTL, transistor logic. Means suppose I want to implement this that gate with the help of transistors only. So that is called transistor logic. Emitter coupled logic. MOS, metal oxide semiconductor. If I use MOS based capacitors to implement this function of NAND gate, then that technology is MOS. And last one is the CMOS. Latest technology is the CMOS technology, where complementary metal oxide semiconductor transistors are used to realize the logic gates. So let us move to the next section, gate level minimization. Yeah. So in our syllabus, map method is given, which is called Karnaugh map. So Karnaugh map is a graphical method of minimizing the function. Minimizing the function means we want to minimize number of literals. Suppose a function is given here, f is given is as x bar y plus x y bar. Okay, we want to reduce this number. Here four literals are used, 1 2 3 4, to express, and accordingly we will require gate. If somehow we are able to minimize this number of literals using algebraic method, Karnaugh map method, or tabulation method, that will simplify the circuit implementation as well as make the faster circuit. The circuit operation will be faster. It reduces the propagation delay time. So this is the main purpose. Now, how can we minimize? Before that, let us see what is Karnaugh map itself. So Karnaugh map, as an example, is given here. Two variable Karnaugh map, K map. It consists of these four squares. Here for two variable, we will see how three variable, four variable, etc. And the leftmost upper square is indicated by M0. This min term 0, min term 1, min term 2, min term 3. M0, M1, M2, M3. And how we have given this name? We have given the name from this logic. Let us see here. Suppose I draw a two variable Karnaugh map, and here I write all possible variables like x bar, x, y bar, y. So if we see this square, so it consists of x bar, y bar. So I write here x bar, y bar, which is written here, and here x, sorry, this one, this is x bar, y, which is written here. Similarly here, if you see, this is x, y bar, and this one is x, y. So x bar, y bar, this one, x bar, y, x, y bar, and x, y. So in this way, we got, and the corresponding min terms are here. X bar, y bar is nothing but m0, x bar, y is m1, x, y bar, m2, x, y, m3. So this is how we can map. We can map a table, tables to table in our Karnaugh map. So now we can see here how to express particular uh, this given min terms in Karnaugh map. For example, I want to implement this f is equal to x, y. How to show it? So you just draw a two variable Karnaugh map. Right here x bar x, y bar y. So you see at this is your x bar y bar, this one is x bar y, this is x y bar, this is x y. So since f is equal to x y, so I will give, the function is giving 1 at x y. So this is how it is represented here. Similarly, suppose function is given f is equal to x plus y. This I have to represent. So to represent this one, we know this x in x1 expression, y is missing. So can we find the y term? So right here x, y plus y bar means we are multiplying with 1. Then y, x plus x bar. So what we are trying to do? We are trying to get the missing variable. We want to express in standard canonical form. So this is xy, this xy bar plus xy plus x bar y bar. So you see here xy is coming 2 times, so we can make it, we can cancel one. Now 3 terms are there. Xy, so f is equal to xy plus xy bar plus x bar y. Now these 3 midterms can be shown in this Karnaugh map. So xy is here, this is xy, x y bar, this is x and this is y bar. So x y bar and x bar y. So here this is x bar and this is y. So x bar y. So all 3 places we have put. So I will show here. So let us write x bar x, y bar y. So xy, x y bar and x bar y. Okay, if you need, you can put here 0, no problem. So this is how we can fill up the information given either in Boolean expressions or through the truth table also. So both kind of information we can fill up in the key map. Later on we will see how to minimize. That is the next part. So now how to represent three variable key map? Let us see 3 variable key map. So 2 to power 3, it means total number of cells will be 8. 8 combinations are possible with the help of 3 variables. So what are those 8 midterms? Those 8 midterms are here: m0, m1, m2, M3. Please mind it. It is not in a serial order. M0, M1, M2 here, M3, then M4, M5, M6, M7. Why it is like that? It is this numbering is based on gray code. Gray code. In gray code, we know that there is a single bit change with respect to its adjacent number. If you compare here, M0 M1 single bit change will be there. Here also single bit, here also single bit change. So maintain this, and that is the feature of gray code. And these numberings are as per gray code. If I want to write two variable gray code, so it starts like this: 00, 01, 11, 10. Our binary number is like this: 00, 01, 10, 11. Okay, so there is need to mapping it properly. So Karnaugh map is drawn based on the gray code. However, your available information is as per binary order. So in order to put proper information, we have to write the correct order of these midterms. So you see here, I will redraw it here for you. You can see 1, 2, 3. So 8. Then here I will take x bar. This is x, y, y bar, z bar, y bar, z, y, z, y, z bar. And now see, this is x bar, y bar, z bar. Means this is 0. X bar, y bar, z 1. X bar, y, z 3. X bar, y, z bar 2. This is x, y bar, z bar 4. X, y bar, z is 5. This x bar, y bar, z, sorry, x, y, z is 7. And x, y, z bar is 6. So 0, 1, 2, 3, 4, 5, 6, 7. This is how we give this number. So this is the three variable Karnaugh map representation. And here it is written here, and respective min terms is also expressed. Now how to fill up this information? Suppose let us see now example. Simplify the Boolean function. F is a function of x, y, z. It means three variable K map. Summation 2, 3, 4, 5. These are the midterms. These are the midterms. So we have to write this function. Gives logic 1 at 2, at 3, at 4, at 5. So this is what is written here: 2, 3, 4, 5. Marked with 1. So we have written Karnaugh map here. And in Karnaugh map, this is M0, M1, M2, M3, M4, M5, M6, M7. As per the function f of xyz is equal to summation 2, 3, 4, 5. This is 2, 3, 4, 5. It gives logic 1 at these positions. So at M2, we are writing here logic 1. M3, we are writing logic 1. M4, logic 1. M5, logic 1. At rest, nothing is mentioned. It means it is a logic 0 here. This is how we can just put up the information. We have not yet simplified. We have just put the information as per the statement of the problem. That can be acha. It is solution basically. Let us now solve it. How to solve it? Yeah. As far as solution is concerned, it says that let us make a group of ones, and this group of ones may be formed based on maximum number of adjacent ones. So since this is a total 8 cells, so what are the maximum possible number of ones in these 8 cells? Maximum possible number of ones are 8. So Highest priority is that if all cells are filled, so we make a group of 8 ones, that is called octet, and it give logic 1. If this is the case, we have to check priority wise. If this is not possible, then we go for making the group of 4 adjacent one. 4 number of adjacent one. What does it mean? It means that if one is here, one is here, one is here, one is here. So this one and this one are in adjacent. But this and this, these two ones are not in adjacent because there is a gap. However, these two ones are in a adjacent. If I write here 1 and 1, then now this one and this one easily visible that they are in adjacent. So we can make a group of 4 ones. That is called quad. QUAD, quad. So if first we see whether there is a possibility of making octet. If yes, make a group of 8 ones and just give f is equal to 1. If this is not possible, then go for looking into making group of 4 ones. So group of 4 ones in this case, it is possible. So that is called quad. There is another provision. This one, let me change the color. This one and this and this and this. If we fold it, if we fold this corner of map, so these two corners come together. They are in adjacent. Folding is possible. So in this way, these two words and these two words can make a quad. So that is called folding. So in this way, 2 quads are possible here. So we go for first octet. If possible, then go make it. If not possible, then go for quad. If quad is also not possible, then we go for the pair. Pair means group of 2 ones, 2 adjacent ones. So for this particular case, which is given in figure 3.4, we are able to make a group of 2 ones, 2 adjacent ones. So this M3 and M2 both are in adjacent. So we can make a pair here. Similarly, we can make a pair here, M4 and M5. Once we have made a group pair, and after making pair, if any literal is not making any pair, then we leave it, and at the end we write its expression, corresponding expression, assuming that there is no further scope to minimize this literal or this midterm. So once we have made this grouping, this group of these 2 ones, that is a pair, then we have to write its what is called minimized literal. So you can see this row wise x bar is common in these 2 ones, M2 and M3. X bar is common, so we write here x bar as a solution. And now go to row wise. These 2 ones consist 2 columns. So we see here y is common. This y, this is y. However, in one case this is y, and in second case this is y bar. So that is why this cancel. Now common is y. So its minimized version is x bar y. Similarly, go for the second one, second pair. If we look row wise, x is common. So we write here x. Column wise, y bar is common. So we write here y bar. Z, here one time it is z bar, another time it is z. So that is why it is cancelled. So we do not take. So now the expressions earlier, how many literals were there? 4 to the 8. 8 literals were there. 8 literals. This f consists of 8 literals. But with the help of this Carnot map, we are able to minimize this function from 8 literals to 4 literals. And this is our job to minimize this function. And now for answer we can write here x bar y, that is the first one, and second one x y bar. So this is how, with the help of Carnot map, we can minimize a given function. That is f is x y z is equal to 2, 3, 4, 5, and minimized answer is this x bar y, x y bar, which is written here. Now coming to next question, also we can attempt simplify the Boolean function f is equal to x y z 3, 4, 6, 7. So let us do here so that we should have proper understanding. Although you can read this book. So here let us write x bar. This is x. Here y bar z bar, y bar z, y z, y z bar. 3. So this is here 0, 1, 2, 3, 4, 5, 6, 7. So I will change the pen color. At 3, logic 1, 4, logic 1, 6, logic 1, and 7. This is 7. Yeah. Now we have to minimize it. So from our observation, we can see that if we take this one and fold it, so this becomes one pair. And if we make this two ones in a pair, so this will be there. Now we can write the answer. So what is the answer? F is equal to, here you see f is equal to x is common, and here z bar is common. Now here yz. Okay, so this is the answer. Now you can see yz here and xz bar. This is the answer. Now you will wonder why I have not made this uh, other pair. Like, this is very much possible to make this pair here, but I have not made because this one is already covered by this one, and this one is covered by M3. So that is why, if even after covering all these things, if I covering another, if I making another pair, then that is the redundant. There is a word called redundant. Redundant. Redundant means extra, unnecessary, not required. So we have to avoid, because our purpose is to reduce the number of midterms, and here you are unnecessary making pair and increasing the group of ones. So that is why that is improper. Okay. So if I write here x z bar plus y z plus this one as x x here y, so this x y is unnecessary things. Okay. Now, so one new terminology we come to know, that is called redundant. So we should avoid to make a redundancy. There is a temptation to make redundant group. So this is written here. If one square is there, which is left, which is not making any pair with a pair, quad, or octet. So number of literals will be 4. Yeah. Okay. Let me read from here. 8 adjacent squares encompass the entire map and produce a function that is always equal to 1. 4 adjacent square represent a term with one literal, that is becomes your quad, group of 4 ones. 2 adjacent squares represent a term with 2 literals, that is called pair. And 1 square represent 1 midterms, giving a term with 3 literals in a 3 variable. Now we can attempt this question also. Example 3.3. F is a function of x, y, z is equal to summation 0 to 4, 5, 6. So this function is given here. Let us see. I will not draw, or let me draw even, no problem. We can draw a corner map. 2, 3, this x bar, x, y bar, z bar, y bar, z, y, z, y, z bar. And the functions are 0, 1, 2, then 3, no, 4, 5, and 6. So we are trying to solve it. So we can see, we can make, after observation, we can see immediately group of 4 ones is available here. Only one is left here, we can make a pair. Now all ones are covered. So if we make group of 4 1 by folding it, we will get f is equal to what is the common here. If we go by row wise, so nothing is common, x bar x. However, this column and this column, last one. So you see z bar is common, z bar, z bar. So we can write here z bar plus another. Next, in order to cover this, we can make only pair. There is no other scope. So we can write here row wise x common and column wise y bar. So we can write here y bar. So z plus x y bar. The answer is z bar plus x y bar. So this is how we can solve this example. Now in example 3.4, it is given as f is equal to a bar c plus a bar b plus a b bar c plus bc. Express this function as a sum of minterms means you have to find out the missing literal. In first one, b is missing. In second one, c is missing. This is complete. And in last one, a is missing. So you have to find out. How can we find out? Just multiplying this term with 1 expressed by b plus b bar. Similarly here, c plus c bar. No need to do. And here, a plus a bar. Then we can find out all midterms and find the minimal sum of product. After that, we minimize with the help of, say, corner map. So from here we can see this is a 3 variable. You can attempt. Let us see. Here it is given answer. Okay, I will do for you here. 1, 2, 3. So here I write a bar, a, b bar, c bar, b bar c, bc, bc bar. So this is your 0, 1, 2, 3, 4. So a bar c. Where is the a bar c? This is a bar. Entire row covers a bar. And where is the c bar? C bar is there in first and last. But first and last also cover your b bar and b. So we can write here 1 and 1 to express a bar c. Okay. Now second, a bar b. Again in this row, a bar is common. Let us see where b is common. So b is common at this place and this place. So we can write, we can choose this one. See, we can see that literal c is available here, c and c bar. So just simply we write here. Now we have covered a bar b also by making here 1 and 1. Third one is the a b bar c. This is the a b bar c. And last one is the bc. So bc is where? This is bc in one column, and missing term is a bar and a. So here a bar is already covered. So now we are able to fill up the information. Next step is to minimize. But from here also we can write down all midterms. So here you can see f is a function of this of ABC. So here this is 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 5, and 7. So 0, 2, 3, 5, 7. 1, 2, 3, 4, 5. 0, 2, 3, 5, 7. Yeah, 5. So 0, 2, 3, 5, 7. You can see why it is not written. How comes 0? A bar, C bar. A bar, C. The B, A bar, C multiplied B plus B bar. So this will be A bar B C plus A bar B bar C. So this is what? 4. This is 4 and this is 1. Yeah, this should be 1, not 0. This should be 1. So this should be 1. So 1, 2, 3, 5, 7. Let us see here. 1, 2, 3, 5, 7. Yeah. 1, 2, 3, 5, 7. So first term was not correct. So we have corrected it from here. So basically this is talking about A bar C. So A bar C, missing term is B and B bar. B. So we can multiply by 1, that is B plus B bar. So A bar B C. A bar B C is nothing but 0 1 1. 0 0 1 1. That is the 3. And this is A bar B bar C 0 0 1. 0 0 1 is the 1. So this is 1 and rest 3. So 1 2 3 4 5. Yeah, at 5 places. So this is how we could write the midterms, sum of midterms. And how to simplify? Let us simplify. Simplify is the next step. I will change the color. So first make a group of 4 adjacent one, that is the quad. From here we can find out answer as f is equal to C, because C is common. B bar here, B and A bar cancel. Plus now only one is this left. So we can make a pair here with this. So making pair gives the result of A bar, and here this is B, C bar. B is common. B C and this B C bar. Sorry, this is not. So this one C plus A bar B. Let us see. C plus A bar B is the answer. So this is how we can solve given function with the help of Carnot map, as well as we have expressed this function as a sum of midterms. Find the minimal sum of product expression also. So product sum of product minimal one, that is the answer. This is the minimal one. Okay. Now 4 variable. Let us see how to draw a 4 variable key map. 4 variable key map has drawn here. So I write here this f is a function of w, x, y, z. So f is a function of w, x, y, z. So here I take w bar x bar, w bar x, w x, w x bar. This side y bar z bar, y bar z, y z, and y z bar. So you see w bar x bar y bar z bar is nothing but m0, then m1, m2, m3, m4, m5, m6, m7. m7 just check. So this is 0 1 1 1. So 0 1 1 1 is nothing but 7. So m7. Then you see there is a one because all information are written as per the gray code. So only one bit change should be there with respect to adjacent and adjacent midterms. That is why M8 start from here. So how it will be? So W with respect to this one, what is the midterms? W x bar, y bar, z bar. So 1 0 0 0. 1 0 0 is nothing but 8. So M8, M9, M10, M11, M12, M13, M14, M15. And in expanded form, it is written here. Now the same formula we can adopt here, as I told you. What are the possible things? So we have to go from here to here. Means first look into the group of 16 adjacent ones. Then go for, if not possible, then go for the group of 8 adjacent one. then 4 adjacent one, then pair, then if not possible, then leave it like that and write the corresponding midterms. If example is given, let us see. Simplify the Boolean function. F is a function of w, x, y, z. This, and the midterms are given where function is equal to 1 r 0, 1, 2, 4, 5, 6, 8, 9, 10, 9, 12, 13, 14. And let us insert this information here. So even I can draw again for you people count of map. 1, 2, 3, 1, 2, 3. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now I will put the information. So 0, so this is 0, let us put 1, then 1, here 1, 2, 2, no sorry, this is 2 is in adjacent, 2, then 4 is here, 5 is here, 6 is here, 8 is here, 9 is here, 12 is here, 13 is here, and 14. So in this way we have filled the information as per the given function. After that we have to solve it. So you just simply see, okay, let me write here also w, x, y, z. So I will use another pen. Okay, so this is w bar x bar, w bar x, w x, w x bar, and let us here write y bar z bar, y bar z, y z, and y z bar. Now let us try to make a group of ones. Okay, so you can see, we just observe, visual inspection says that these ones are in adjacent, these 8 ones are in adjacent, that is the group of 8 ones we can make octet, that is the group of 8 ones. After that, in order to cover these 3 ones left, try to make maximum number of adjacent one. So if we fold, so these 2 words and these 2 words can make a group of 4 words, that is called quad. And this one is now left. If we take these 2 words and these 2 words, that also makes you another quad. So one octet and 2 quad are possible. So let us write the now answer. Next term is to write the answer. First octet. So this octet gives the answer of, see, if we go by row wise, so everything cancel. Only 2 columns are there. In these 2 columns, y bar is covered. So straightforward, we write the answer as a y bar plus. Now go to this quad number 1. I select, suppose, this quad first, this one and this one. So it covers 2 rows, w bar x, w x. So this x is covered, so I write here x, and go for this columns, 2 columns. So you see here z bar is covered, so we write here z bar. So solution of this first quad is x z bar. Now coming to second quad. Second quad is made of these 2 ones and these 2 ones. So here also we can see row wise w bar is covered, so I write here w bar, and column wise is z bar, so I write here z bar. So this is the answer. Let us check. This is y bar, here y bar, w bar z bar, w bar z bar, x z bar, x z bar. So this answer is now correct. This is how it has been solved here also. So another attempt can be done. This So example 3.6, simplify the Boolean function. This function is given. From here we can see f is a function of four variable, because this expanded one tells that function consists of four variable a, b, c, d. This is four variable, and either you write all midterms, because here d is missing, here a is missing, here d is missing. So find out all missing term and write down in terms of summation and all this, and fill up in the Carnot map and make the quad pair and whatever possible things are there, and write the answer. So this is the example is given. Please try to attempt it and you will get the this answer. So with this, I would like to conclude this class, and later on we will understand what this prime implicates. Thank you so much. This way we are concluding lecture number 8. Have a great day. Bye.